In this video, we're going to cover density and unit conversions involving density. So for this quiz, you're going to need a calculator. So if you want to grab a calculator, feel free to go ahead and do that. All right, let's talk a little bit about density and what it is. This over here is actually a Galilean thermometer, which is a really cool device if you've ever seen one. It actually works based on density. So inside of each of these little baubles here, there's also a liquid in here. These are all liquids. There are different types of liquid. And so each of these liquids has a different density. And if you look here, these little tags will have readings on them. There will be a temperature here. And you can see what temperature it is based on where the little baubles are floating. And this is determined by density. Things that are really dense are going to go down to the bottom, and things that are lightweight and not very dense are going to float up to the top. Right. So let's take a look at another example of this. This is actually a really fun thing to do at home. You can do this with kids a lot too. I know a lot of you are education majors, so this might be something that you actually want to do. So if you're thinking about using that in future classes, you'll be able to. You can make what's called a density tower. So what this is it's substance after substance after substance of things with different densities. So down here, honey is the most dense, and you can actually stack these on top of each other. Corn syrup, maple syrup, then milk. I think, okay, dish soap and then water. They've stained the water green. But what you'll find is if you put all of these things, you kind of layer them in, you put the bottom one in, and then the next one, and the next one, they stay where they are. After, you can let it sit overnight, and everything will separate out very neatly. Because of the specific densities that each of these liquids have, the ones with less density go to the top, like the lamp oil, and the ones that are the most dense, like the honey, go down to the bottom. We can see that when we drop objects inside of our density tower full of liquids of different densities, that our solid objects settle in the area in which their densities are the same. So something like a ping pong ball here is full of air. So it's very, very lightweight. It's not very dense. And so it actually sits on the top of the density tower here. I think this is like a tomato or something. It sits right around water. Tomatoes are composed primarily of water. So it should probably actually be in here. It seems to be in the dish soap layer. So it's a little bit denser than water. And then if you see down here, there's a bolt that they've actually dropped down into the density tower, and metal is very, very dense. If you remember from last topic, you saw that the metal atoms are really close together in their crystalline structures, and they tend to be very heavy, right? Density is based on mass. So something that's really heavy tends to have a high density. Okay. You can see a couple other things that they've dropped in here. Yeah, that was a tomato. There it is. Okay, beads, soda cap, dye, popcorn kernel. Anyways, this is a fun experiment you can do at home if you're bored one day. All right, so let's define what density is. Density is the ratio of the mass of an object to the volume of the object. So this is your mass over your volume. So it's how much mass you have in a specific space. So how much mass is in here. If you have, say, something this size that is 2 pounds, it's going to be heavier, or it's going to have a higher density than something that is the same volume, the same size, but has a mass of 1 pound. That would have a lighter density than the same size object that has a heavier mass. So that's kind of what we're talking about here with density. Now, in chemistry, we often determine density using what we call water displacement. This is an experiment that lets us determine the density of an object, because sometimes it's hard to measure volume, right? Not everything is a nice square or circle, and we don't have equations to model the size of it. Like this piece of rebar here has random little jagged surfaces, so sometimes volume is hard to measure. Mass is pretty easy. We can just put that on a balance. So one way that we can measure volume very easily is using water displacement. So that's why we're using this method to measure volume, because it can measure any volume regardless of its shape. So what we do here in order to measure water displacement is you have a measuring device that you fill with water, and you can put a solid into the water and measure the change in the height of the water. And this tells us how much of the water was displaced by the object, because the water can't fill the area that the rebar now is occupying. So we see that water go up. So our initial volume here was like 13.5, and then after the rebar is added, it goes up to 22.4. So if we wanted to know the volume of the object, we can simply take the difference here. So it's 22.4, this is milliliters, minus 13.5 milliliters in order to get your final volume. So the density of this object would be 8.9 milliliters. Here we have a mass of the object. So this would be if you measured it on the balance and the balance gave you this number. So we have our volume, we have our mass, which is 69.658 grams. In order to determine density, if you remember the formula from the previous slide was density equals mass over volume. So in order to find the density of the rebar, we can take this volume, or take the mass and put it over the volume in order to find the density. Okay, so the mass goes on the top, 5.8 grams over 8.9 milliliters. So the density of this object would be 7.827 grams per milliliter. So the unit on density, so the density unit is anything that's mass over volume. The most common one you're going to see is grams per milliliter. You could also see kilograms per milliliter or grams per liter, as long as it's got something that's a mass over a volume. Now I want to point out something that you may see, just so you understand it. I'm going to clear all these pen markings, so hopefully you have everything written down. Pause if you need to. Now, one unit that you may see that might be a little confusing to you is the centimeters cubed. This is a volume. I want to emphasize that. The way this is a volume is because of this explanation right here that we're going to go over. So if you look at a square, or a cube here, if you define something by length times width times height, so length times width times height, we're going to get the volume of something. So say this is 1 centimeter here, 1 centimeter, that's the number 1. 1 centimeter by 1 centimeter here on this cube, and this cube is also 1 centimeter deep. We can say effectively that this entire cube is 1 centimeter times 1 centimeter times 1 centimeter, which is equal to 1 times 1 times 1 is 1, so it's 1 centimeter cubed, because a centimeter times a centimeter times a centimeter is 3 of those, so it's a centimeter cubed. So that's the volume of this cube here. So this, if you notice, it occupies an area. It occupies this volume. It's a 3D space. So if you see this centimeters cubed, it is a volume. Another conversion factor that will be useful for you to know in this class, I would suggest you memorize it, is that 1 centimeter cubed is equal to 1 milliliter. So this same cube occupies 1 milliliter of volume. So go ahead and write this down, make sure it's starred, highlighted, whatever you need, because that is an important conversion and you will need to know it for this class. Okay. Something else that you need to know, I kind of hinted at it earlier, but every substance has a specific density. This is a physical property that is characteristic of the substance itself. So if we look here, there's a table of different solids, liquids, and gases, and they all have their own unique densities. Now some of these are similar here, like milk, soda, and seawater. They're about the same density. But everything else has very specific values. So sometimes this can be really helpful when we're trying to identify a substance because it's one of the properties that we can use to figure out what something is. So maybe we have like an unknown solid that's come to us. This happens if you ever work in a chemistry lab. This actually happens really frequently. Someone will send you something and be like, figure out what this is, and you have to figure it out. So this is a really helpful method for that because density is characteristic of a material. So you can kind of narrow it down to what material it is based on its density. Okay, ignore this. Okay, so try this problem on your own. Make sure you identify the unit that you're starting with, the unit that you want to end up with. You'll need the formula for density. It equals mass over volume. I think for this one, actually there won't be unit conversion involved in this one. We're okay here. So you don't need unit conversion for this one. But solve the density, find the density, and then figure out what substance that you have based on this table, what the substance is likely to be. Okay. Let's take a look at how to solve this one. So you measure out 20 milliliters of an unknown liquid. So this is your volume in the lab, and it weighs 21 grams. So this is your mass. Using the reference table, what is the most likely identity of this substance that you have, of this liquid? So we've got a couple of liquids to choose from. So we're going to go ahead and solve for this one. So we're going to put mass, grams, over our volume. That gives us a density of 1.05 grams per milliliter. Now you'll notice I wrote out this unit. I would suggest in this class that you always write out units. Just because it's going to come in handy down the line. Okay, so if we look at our tables, we see that this is the one that's closest to that density, so it's most likely seawater. Another thing that you're going to need to know for density is temperature conversions. So something that you might not have noticed on this last slide is that this density down here is at a specific temperature. Density at room temperature, which is 23 degrees Celsius. The density of these objects changes when you have them at different temperature. Specifically, gases and liquids will do this a lot. Densities of solids don't change much depending on the temperature, but the density of liquids and gases do. They depend on the temperature because temperature is energy and it moves molecules around. So sometimes you might be asked to find the temperature of something at a different value, and you might need that for density. So let's look at how to convert between Celsius, Fahrenheit, and Kelvin. These are the different types of degrees you're going to be using in this class. So you might be given a value in Fahrenheit and need to convert it to Celsius, or Celsius to Kelvin, vice versa, whatever. So this is the formula. Go ahead and write this down. You will need it. So this is your Celsius value here, and this is your Fahrenheit value here. So say you had something that was, let's see, let's check out room temperature. So let's verify 72 Fahrenheit. Let's see what that is in Celsius. So 5 over 9 times 72 minus 32. And let's see what temperature that gives us in Celsius. So this is 40 here. So 5 over 9 times 40 gives us 22.2 Celsius. So pretty close to 23. So 23 is actually a little hot. That's warmer than 72, which is what we consider room temperature in Fahrenheit, I believe. Okay, let's look at Kelvin. In science, a lot of times we use Kelvin because Kelvin is like an absolute scale. So 0 on Kelvin is like absolute 0. It's the point at which molecules stop moving. So 0 Kelvin is absolute 0. That's when molecules stop moving. So this is actually a very difficult temperature to achieve. It's very, very cold. So let's check out how cold that is. Let's try 0 Kelvin, and see what that is in Celsius. So what we're going to do is we're going to take 0 here because that's our Kelvin value. So absolute 0 is equal to our Celsius value here that we're going to determine plus 273. So to get to Kelvin from Celsius, it's a lot easier. You just take your Celsius value, you add 273. Here, we're going to be solving for this. So solve for this. So you can assume that's like an x in algebra. So we're going to get rid of the 273 on both sides to isolate our variable here, our Celsius. And so minus 273 is equal to our Celsius value. So 0 Kelvin is minus 273 Celsius. That's very cold. Let's see how cold that is in Fahrenheit. Minus 273 Celsius is equal to 5/9. So Fahrenheit, we're going to solve for that. Again, you can assume the capital F for Fahrenheit is like an x. We're going to solve for x. Okay, so the first thing that we need to do is we need to, I'm going to multiply both sides by 9/5 to cancel this. Okay, so 9/5. There are multiple ways to solve this, by the way, if this is confusing. So if you have a way that makes more sense to you, please do that. This is multiplication here. So 9/5 times minus 273 is going to give us negative 491.4, which is equal to Fahrenheit minus 32. All right, now we need to get the Fahrenheit by itself, or the x value. So I'm going to add 32 to both sides. Minus 459.4 degrees Fahrenheit. That's absolute 0 in Kelvin. That's a really, really cold temperature. So that might give you an idea of how cold absolute 0 actually is. So you will need to memorize these formulas. You're going to need to know how to convert from Celsius to Fahrenheit and back and forth, and Kelvin to Celsius as well. Okay, so give this a shot yourself. Find out what 23 degrees Celsius is in Kelvin and Fahrenheit. Here are the equations for you. Remember that this is algebra. You're solving for x. If you need a reminder about how to do this, you might remember this. PEMDAS, which is the order of operations. In mathematics, we first solve for parentheses, exponents, multiplication, division, addition, and subtraction. Let's take a look at the answer for this one. So 23 Celsius. So we're going to put our 23 in here, 23. We'll also do that for this one. That's where that value goes. 23 equals 5/9 times our Fahrenheit. I'm going to put in an x here. This is our Fahrenheit, just so maybe it makes a little bit more sense and it clicks for you. All right, so let's look at our order. We want to solve for x, so we need to get x by itself. All right, so I'm going to go ahead and get rid of my multiplication and division. This is in parentheses, but if you look, there's an x in the parentheses, so we can't actually do anything with that stuff in the parentheses. It's actually going to come last here. So we're going to do our multiplication and division first. I'm going to use the inverse of 5/9, multiply both sides by that in order to cancel this out, because 5/9 times 9/5 just equals 1. So that's why we can do that. 41.4 is equal to x minus 32. Okay, so in these parentheses, now we can get rid of the parentheses and multiply each side by 32. Sorry, add 32 to each side. If you do that, you end up with 73.4 is equal to x, which is your temperature in Fahrenheit. So 23 Celsius is 73.4 Fahrenheit. Let's check out the Kelvin value now. This one is a lot easier than converting from Celsius to Fahrenheit. So it's literally 23 plus 273 is going to give you your Kelvin value. So this is much easier. So that's 296 equals Kelvin. All right. So that's the answer you should have gotten for this. Let me know if you have any trouble with the algebra. There's going to be a lot more of this in this class, solving algebraic equations. So if you need any help, go ahead and get help early. The Math Enrichment Center can help you with this. A chemistry tutor can help you with this. I can help you with this. It's okay to reach out in regards to math if you are having some trouble solving algebra. So that's it for density and unit conversion in relation to density. There will be more example problems like this on your homework that kind of tie this concept together.